Well, hello everybody. My name is Clemens Prerovsky. I work as a general manager for Gentex. We're an Austrian CMS vendor, and we're part of the Austrian press agency. 2008 was a super exciting year for us because in 2008, for the very first time, we were creating our first REST API. We've used REST APIs before that, of course, but we've never created our own. And in 2008, we decided that we will take our enterprise CMS and we will add a REST API on top of that. We didn't really have any idea on how to structure REST API, how to structure the endpoints, but that was no problem at all. We just sat down. We're a team of 5 or 6 developers back then. We just sat down, we sat together, we drafted the API. And the cool thing about REST APIs is that they're incredibly easy to build, they're incredibly easy to consume. So we sat down and we went at it with full speed. And it was great. It was super awesome. It worked out pretty well. I mean, there are hardly any regrets I have about our API back then. Now, let's fast forward to 2015. Where we released an entirely different product, where we released Gentex Mesh. It's an API-first CMS. So this time around, we've changed things up quite a bit. The API is now the core of the product. So it's not an add-on to an existing product. The REST API is at the core of the product. And I thought, why don't I take my experiences from the past years, and if I add them up together in a talk, that would be a quite interesting talk, and that's why I'm standing here today. But that's enough about me. The first thing I want to do, I want to introduce you to Roy. His full name is Roy T. Fielding, and he's quite an awesome guy. In the past years, I've stumbled across his name quite a few times, but I didn't pay too much attention, I have to say. But when I did my research for this talk, his name kept coming up more and more often. And as it turns out, Roy has a hell of a track record. He is the primary architect of the HTTP 1.1 specification, so I think that influences all of us. He is co-founder of the Apache HTTP server project. That affects all of us. And the reason why I'm talking about him today is that he wrote his dissertation back in 2000 about network-based software architectures. That's not the actual title, I just slimmed it down a bit. Or for us, he wrote his dissertation about REST. So back in 2000, the guy sat down, wrote his dissertation, and he came up with the idea about how the web and applications in the web work today. He defined the way that we think about REST. And the way we think about REST tends to be that we think about machines or applications interacting back and forth with each other. It could be a website interacting with a server, exchanging data with a server, or it could be, for example, my mobile phone exchanging data with a server. And while that's technically correct, and that's the way he described it, today I want to give you an additional angle. I want to give you an additional view of how we can think about REST APIs. Because I think we should think of REST APIs too, in a way, as if 2 people are having a conversation. Since this is a developer conference, I assume you will be sitting on the giving end. So think about, what can I do as a developer when you're creating your REST API? What can I do for the guy that actually needs to consume that thing, that actually needs to use the thing that I created? What context is he in? What are the tools that he's using on a day-to-day basis? What is his knowledge of HTTP? And how should that affect my REST API? And I think if we're really good at what we're doing, and if we really take the time to sit down, then this guy will say, aha, somebody understood what I was trying to achieve. Somebody cared about my problems, and he made this thing incredibly easy and comfortable to use. By the way, I think this hedgehog is enjoying the belly rub way too much. All right. I've structured my talk in a top 10 fashion, and the reason is super simple. that format is insanely popular right now. Top 10 lists everywhere, so that's why I went with top 10. And it has another advantage. Should my talk turn out to be really shit, then at least you know how long it will drag on. So that's a plus there too, only upsides. And spoiler alert, there's one bonus topic at the end, so it's not even a top 10 talk, it's a top 11. All right, let's get right into it. Number 1, endpoint naming. And the first thing I want to show you is this painting by Peter Bruegel the Elder, who painted it in 1562. And they had very similar issues. You won't believe they had very similar issues compared to us these days. That's why he named this painting REST API Programmers Discussing Naming Conventions. So you can see the Rastafarians at the top left here proclaiming the ultimate naming scheme for REST API endpoints. Now, today I'm not going to proclaim the ultimate naming scheme, but I'm going to tell you what I think is the most popular approach and what is the approach that worked for us. But let's look at an example first. Like, this is pretty similar to what we've started out with back in 2008. And back then it didn't look all that bad to me. I mean, get all nodes, that's pretty obvious to me. It gives you all the data nodes that are stored in the system. I mean, how wrong can that be? And my question for you at this point is, are we happy with an endpoint like that? Yes, correct. If I'm asking that way, no, we're not happy with an endpoint like that. And the first thing I want to point out, it's a semantic thing. I mean, that might not be the most terrible problem in the world, but it really is a semantic thing because hopefully at some point in time, somebody is going to come along and he's going to issue a GET request. So he's going to get all nodes. And that's not, I don't know, that doesn't roll off the tongue very nicely. And there's a load of other issues. But let's look at my proposition first, because what I would suggest you to do is just to use the nouns. There is a reason why there are HTTP verbs. They take care of the verb part, so we can stick to the noun part. So get nodes would be my suggestion. And there's one thing special about this. It's not only a noun, it's a plural noun. I think it's a great idea to always stick to plural nouns. And why should you always stick to plural nouns? Sometimes that might seem off or feel a little bit weird if you like only have one item there. Still, go with plural nouns because this way you can spare the developer the effort to have to look up the documentation every time to figure out whether it's a singular endpoint or a plural endpoint. You want to have a consistent API so that it doesn't have to look up stuff. So now that we've got plural named endpoints, we can do stuff like post to nodes, get nodes, put nodes, and delete nodes. And it all works the same. Imagining posting to get all nodes, now that hurts a little bit, at least in my book. All right, so my first message to you is use plural nouns. And I'm going to back that up with the exception from the rule. Chuck Norris, as always. And the Chuck Norris of REST endpoints is the search endpoint. Don't use plural there. Don't go with searchings, I don't know. Just use search. Everybody uses search. All right, moving on to number 2, HTTP verbs. And these are probably the most common HTTP verbs. I mean, post and get are the most common, and put and delete. I think everybody knows that put and delete exists now. And you might also know that they share a very rough relation to create, read, update, and delete. It's not an exact relation, it's not a one-to-one relation, but it's a very rough relation. And why is the relationship between them only rough? That's about the specifics of post and put. Let's take a quick look at how post and put work. The interesting thing to know is that post and put both allow you to create and update resources. So why do they exist if they both do the same thing? Now, if we look at post, post will allow you to work with partial data. Post will allow you to work per the HTTP specification, to work with incomplete data. So if I have users on the server and I want to update a user who is coincidentally named like me, he is also named Clemens, I can only send the first name to the server, and that's totally okay. Of course, your application needs to allow that too. But the HTTP specification tells us we can send incomplete data. Whereas with put, we're supposed to send all of the data at once at all times. That means if you want to create a data set on the server using the put method, you will need to specify the ID. You will need to generate an ID on the client and send it to the server. And the reason for this difference is that put is defined as being an idempotent operation. And this, ladies and gentlemen, is the most important slide of my presentation because it includes all the party knowledge you need to know for tonight. Idempotent is the most important word in REST. I've watched many REST API talks in preparation for this, and this is in every talk. Maybe we want to practice it a little bit together, idempotent. And with all the party knowledge, it helps to understand what it means. Idempotent just says that you can repeat the operation over and over again, and the outcome on the server must always be the exact same. So if we take a look at the previous example, that means if I always send the complete data set, I have the guarantee that the outcome will always be the same because I sent the complete data set. But if I only send partial data, somebody could have changed my email address or the last name in the meantime. I don't know nothing about that. So that's why put is idempotent. I've used the fancy word. We can move on. All right. So you might ask, what about the other HTTP methods? What about the head and the options and stuff like that? And that's the first time I'd like to make a reference to my opening, because at this point, I want you to consider what is the developer who is actually going to use the API capable of? What is he comfortable with? Is he using options requests to the server? Imagine this. He's sitting at his desk and he has to finish his stuff in like 1 hour. And then you make him send an options request to change his user settings instead of just using post. So he has to go to the manual, look that up. He might have to look up how options work because he's never done it before. The interesting thing about REST APIs is that you can really make work all of it with just get, post, and delete, and it's totally according to specification. You don't even need to break specification. So think about that and limit what you're using. It really helps the developers. So cater to your audience. Moving on to number 3, subresources. All right, so that's the API I proposed in the beginning. And in this example, we are retrieving a single data node. Now we have our data node, and it helps to organize data, you know. And one popular scheme of organizing data is using tags. So we want to tag things, maybe. And there are several approaches. I picked 2. And the first one is you just add a tags endpoint. And if you want to read all the tags that a specific node is tagged with, you can just supply a node ID. And that's okay. That's a totally viable way to do it. I think there is a better way. The better way is to use subresources, because subresources offer you a more semantic approach to retrieve data about items that you've loaded. So you can really semantically structure your API this way if you use subresources, and in this example, you would retrieve all the tags that the node with the given ID is tagged with. So express relationships between resources using subresources. In the world of REST, not all the things can be super easily explained just using get, post, put, and delete. Sometimes there are challenges, like for example, likes. It's not that easy to express likes or favorites or +1s with the basic HTTP scheme. Of course, there's a solution to that too, because let's look at the data model first. What you could do is, and that's not a very great approach, what you could do is you just could add a likes property. For example, let's say you have a blog post, you add a likes property, and then you add all the user IDs or the usernames that like this blog post. Now, if you go down that road, then you have to send that array back and forth all the time. If 2 people at the same time read a blog post, and everyone wants to give it a like and send it back to the server, you will have a conflict. So that's not a great route to take, but you have to sit down and think about what approach could I take. And a possible approach for that is you could just use an action subresource. And action subresources work exactly the same way that subresources work. You add them past the ID of the node that you want to change or the resource that you want to change. And now you can interact with it as you would with any other resource on the server. You can get the likes, you can put new likes or update the likes using put. You can delete likes of a user using the delete request. So that's a really comfortable scheme of interacting with things. Moving on to number 4, data formats. And I think it really is Marie Curie who said it best when she said, use JSON. XML will make your hair fall out. And coincidentally, I totally agree with Marie when she said that. But that's not my core message here. My core message is decide for one single output format. Just go with one single output format. And let me tell you a story about that. Because back in 2008, we were using a serializer that would allow us to both generate JSON output and XML output. And back then, we decided to go with XML as our primary output format. But JSON was in there for free, so we just let it switched on. We just kept it on. I think we documented that you could use it, but there was no further documentation about that. And the thing is that everything worked well for years and years and years, until one day, one of our customers accidentally read the documentation and discovered that he could use JSON as an output format. Now, as it turns out, JSON and XML are not the same. They are quite different. And stuff that works with the XML output and has worked with the XML output didn't work so great with the JSON output. So my message here is just switch the other stuff off. Like invest a minute now, switch the stuff off, and spare yourself the expense of having to fix stuff that you didn't want in the first place in 5 days or 2 weeks later on. Models and resources. So, most of the time when you have an existing application, hopefully you're going to have a data model. And what I see happening, and that's what happened with us, so we're no exclusion to the rule, is that most of the time people, when they add a REST API to an existing product, they just slap it on top of it. It's just like you make GET requests to the table names, and they make it out, blurred out JSON at the back end, and then everything fine, that's the REST API. Obviously, that's not a very good way to go about it, but it keeps happening over and over again. And what I want you to do is, I want you to sit down and think about the REST API. I want you to go about it the same way as you would designing a user interface. Hopefully, nobody is just taking a table and outputting the data in the exact order that is stored in the table. When you design a user interface, you think about the user experience. You think carefully about how to lay things out. You might even combine data from different models into one single UI. And that's something you can do with REST APIs too. You don't need to exclusively present data from a single data table, from a single model. You can combine data according to the way that the implementer will actually use your REST API. So please do that. Carefully craft your API. Don't just re-implement your existing data model. Number 6, status code. Status codes. Now, if we take a look at a request that looks like this, I'd be really suspicious if you'd send me an HTTP 200 code. Now, we all know that the 42 part at the end is correct, so no issues with that, but the rest is really weird. So either you have a rather exotic REST API, or it should return anything else but an HTTP 200. So please use the correct HTTP status codes. Use the HTTP 400s if the developer using your API messed up. Use the HTTP 500s if you messed up, if something is broken on the server. And for Christ's sake, please add a description. Imagine this. I've got this super simple example. The developer just has a typo in the URL. He just, instead of nodes, he requested those. And imagine how hard it is to figure that out when that thing just says HTTP 200 OK. It will take you some time to figure it out, but with this simple message, you can make it all work pretty fast and remove some of looking up the documentation, some of the frustration. So use the correct HTTP status codes. Number 7, path parameters and resources. Now with REST APIs, you can do some amazing things, or pretty nice things. For example, if you have data that is structured in a hierarchy, that is structured in a tree, you can make it accessible in a scheme like that. So you can use the name of the data nodes, for example, and make them accessible like a path. And that's fine. However, if you do something like this, and I personally drafted the upcoming vault, if you do something like this, you never ever want to do something like this. You don't want to add in an API endpoint that can be at an arbitrary level there. You just can't do that. Of course, you're going to have naming conflicts, and your API is going to be inconsistent. It's going to be hard to predict for the developer whether stuff works and how it works. Of course, the correct version to do this is to move the API endpoints up front. The top one to browse the folder structure to load data nodes that are stored at a specific path. And the bottom one to generate a breadcrumb navigation for the exact same path that you can output, for example, on top of an article. So never ever mix parameters and resources. Number 8, API versioning. I'm going to compare the two most popular approaches to API versioning. The top one is versioning your API using the URL, and the bottom one is using a HTTP header, in this case the accept header, in order to request a resource with a specific API version. And I'm going to walk you through what this means for the developer consuming your API actually means. All right. The first thing, that's some jQuery pseudocode. In the first example, if we version using the API, he can just use the getJSON method. He can access the path, drop in a success callback, and he's done. So that's pretty easy, pretty basic stuff. In a second example, however, I mean, it's not too complicated, but he can't use the getJSON method anymore. He has to use the more generic Ajax method. And this time he needs to specify his own HTTP header because he wants to add the version number at the back. And that might not seem too bad, and you can easily abstract it into a function. So that's not that much of a hassle. But what you can never do when you put too much of your application parameters into headers, what you can never do is you cannot enable browser access. And browser access is one of the fundamental tools that your developers consuming your REST API will use. They will just, if something doesn't work, they will take the URL and they will put it in the browser to see what is actually coming back, and you want to enable them to do that. Don't do something like figuring out, oh, he's using a browser, I'm going to forward him to the documentation. He really wants to see the data that is coming back because it's the easiest way of debugging stuff with REST APIs. One more word towards version numbering. You might recognize the semantic versioning scheme. Now, that is not a thing for REST APIs, not at all. With REST APIs, you're allowed to use version 1, 2, 3, 4, and 5, and that's it. You may never go past 5. If you go past 5, you need to relaunch your product with a different name. No, it's just that really doesn't make sense. People are going to go insane if you change your API that much. Really consider when you bump up your version number, then that's a really big thing because all the developers need to change up their stuff. A nice thing about REST APIs is, though, that usually you're able to add new fields in the data without breaking existing application. But that really depends on your REST API. Most of the times, that's the case. You can work around that a little bit and prolong specific API versions. Tell nobody that I told you that. All right, number 9, state. Dealing with state. And I need to give you a little context for that example. Because our API, first CMS mesh, it uses schemas to describe the type of data you want to store. You can store arbitrary data nodes, and you use a schema to describe how that data is structured. Now, we figured out that people might want to change the schemas over time. Not everything stays the same. And for that purpose, we have migrations in order to allow the system to migrate an old version of your data to the newest version of the data. So if you want to view an old version of a blog post, for example. And for that, we drafted a REST API that looked like this. I said we drafted it. We never put this into code. I want to emphasize this. And this is probably the most horrible way you can go about it. That's like really, that's the most horrible way you can go about it because it is super stateful. Let's take a look at the endpoints. There is an init call to initialize a migration. You can leave that hanging there forever. There is a dry run to test stuff. Then you can actually run it. You can retrieve the status, and you can commit stuff. And should you catch yourself drafting out an API like that, then you know something is off, and you need to go back to the drawing board. You need to sit down again. That's what we did. And we combined it down into 2 endpoints that are totally stateless now. And that looks pretty simple, actually, but it's quite a lot of work to go back and do this, and it's really not the most fun work to think about, oh, how can we make this stateless? Now we've got a diff endpoint that tells you the difference between one version of a scheme and the other version of a scheme, and how to migrate, how the server would migrate the data. You can change that. And then we've got a migrations endpoint that allows you to post the migration, and the server will carry out the migration. All right, so what you don't want to do is you don't want to have chatty APIs. A chatty API is an API that requires a lot of back and forth. So you need to go to one endpoint, and then you need to go to the next endpoint, and then you need to go to the next endpoint, and you take the data and input it to the next endpoint. That's absolutely not the way you should do it. You don't want to be chatty. You want to be absolutely stateless. And this brings me to number 10, IDs. I've prepared another example, and I really have to say this one feels right at home for me. I mean, that's auto-increment IDs. I don't know how long I have used them, and I have to say I really love them to this day. Unfortunately, it's not a very great idea to use them that way. Because at some point in time when you've got the system up and running, you might want to have a test server, and you might want to have a development server, and you have your production server. And somebody is going to have the idea, oh, we did all that stuff on the development server, we did all that stuff on the test server. Can't we just take that and move it to the production server? And if you use auto-increment IDs, if you use integers like I do so, then you're guaranteed that there's going to be an object on the other server that has the same ID and conflicting content. So it's just not the same object. And then you're welcome to the land of the great ideas like, oh, we could offset all the IDs by 10,000 because we're only at 5,000 at the server. And all that stuff, and you don't want to do that. You don't want to go there. And that is why we at Chantix, we use unicorns to identify our data. They are very unique, so that's the most unique you can get. The thing is, should you not have any unicorns available, it is also okay to use UUIDs. That kind of works out. I mean, they look like shit, let's be honest here. Nobody can remember the stuff, but they get the job done, and they are way better than just plain IDs, just plain integers. You're going to have so much fewer problems. So go with UUIDs. All right. Moving on to the bonus chapter. And the bonus chapter is about REST clients, REST API clients. Now, if you've used any recent REST API-based service, then you've seen something like this. You've seen that they offer a whole amount of client integrations, a whole amount of API integrations. And you might have wondered, how do they do this? How do they do the housekeeping with all of those client APIs? And we have some experience with that too, so I thought I'd share it. And in order to compare the different approaches, I have prepared a scientific chart with coding effort on the y-axis and the grade of automation on the x-axis. And I'm going to walk you through the approaches. And the first approach, and that's also historically the first approach that we have picked, is the roll your own approach. This means you're going to code everything yourself. And the roll your own approach has one great advantage. It's super customizable. You can really cater to the developers who are using your stuff. You can make stuff that's a little bit complicated to use. You can make it more easy. And it's just great in regards of customization. And when you start out with the roll your own approach, things don't look so bad. I mean, it's some work, but it's okay. You can do it. And then you will recognize, for the first time ever in IT history, at around 90% of the project, oh, it's going to take longer. So that's why I would not recommend to go through the roll your own approach again. Unless maybe if you have like a single API, it might be worth considering, but you should rather have a better REST API so that you don't need to fix that much in your client. All right, moving on to the next one, the generic approach. And the generic approach is about, it's a bit similar to the roll your own approach because you're coding the client yourself. You can use some basic libraries though. You're coding the client yourself, but this time, instead of coding each individual REST API endpoint as a method, this time you're going to code the HTTP methods. Your client is going to have a get, put, post, delete method. And what the implementers using your client API will do is that they will use the actual REST API. They are going to use the endpoint URLs and input them into the methods. And the thing about the generic API approach is, what you can do is you can automate some of the basic stuff. You can automate like authentication and adding language headers and adding versions to the API calls, so you can make it a little bit more comfortable. The next approach is the auto-generated approach, and I think everybody has been waiting for that, and we've used it too with great success. In the Java world, this really works. I mean, for us, I feel it's not as good as going with a generic client, but still you get a pretty great result with the minimum amount of effort. Those clients just work, and you can totally use them. The thing is, if you're not in the Java world, if you're, for example, in the Node.js world, in the JavaScript world, that stuff doesn't work out all that well. I have yet to see an example where a usable client is generated using our AML specification. So that didn't work out for us at all. So I totally suggest you to roll with the auto-generation approach, but only if you're in the Java world, if you can make it work. The last one is just there to remind you, it's the none approach, not having a REST API client at all, because I think that's a totally viable option. It's totally viable. There are enough like generic client APIs available that make it easier to interact with REST, so you could not have a client at all. At the moment of this talk, I'm in favor of the generic approach. That's the best value for me now. If you ask me in 2 months from now, I might have a totally different opinion. So don't put too much in it. I think you need to test and try. All right. So to sum things up, try to be minimalist, implement not too many features, focus on some few features that you execute really well. The less features you have, the more maintainable the stuff is. You don't need 5 output formats unless that is the core value of your product. For all the other cases, go with one single output format. Be consistent. Developers don't like looking stuff up in the documentation. Nobody ever reads the documentation. So try to be consistent. When they've learned something, they can reuse it throughout the whole API, considering data formats, considering Node API endpoints. And the last one is be your customer, become your customer. Try to think like him. Try to think like the poor guy who has to use that thing and make it work for him. All right, here's a slide with a sad puppy. Please vote for my talk, unless if you didn't like my talk, then you can safely ignore this slide. If you like to check out what we're doing, then hit getmesh.io. This is the part where they say thank you so much for your attention, for coming here. Rest in peace. And if you've got questions, we've got some time left. Thank you very much.